This is a linear equation, but it is not actually homogeneous. How can we solve this equation? How can you find the solution to this equation? Now I need to write a dy over here. Now the first thing you need to do, you need to take out the values of the functions in terms of x and y and solve them simultaneously. So we are actually going to have 2x minus 5y plus 3. And this will be equal to 0. Here you're going to have 2x and this will be plus 4y and this is minus 6 and this is also equal to 0. Now if you wanted to solve this using the elimination method, we can actually subtract this equation by this equation. That is taking this equation and subtracting it from this one. So let us do that. That is going to cancel these ones out and you're going to have minus 5y minus 4y. So that is going to be minus 9y. And on this side we're going to have 3 minus negative 6. So that is going to give us a positive 9. This is equal to 0. From here we have that minus 9y is equal to negative 9. So we have y, so b equal to 1. Now we need to take y, which is equal to 1, and plug it back into any of the equations. So let us say we take it into equation 1. Now that is going to be 2x minus 5 multiplied by 1, and this is plus 3, and this is equal to 0. So we have 2x, and this is going to be minus 5 plus 3, that is minus 2. This is equal to 0, so we have 2x, which is equal to 2, and we're going to see x is equal to 1. Now as it is, we have y is equal to 1, and we also have x to be equal to 1. What that means is that we could actually solve this using the method of homogeneity if we actually made x to be equal to x plus 1. That is x equal to x prime plus 1. And if we made y to be equal to y prime plus 1. That is because we found these ones. So that will be the next thing to do. So let us plug that back. That is going to give us 2, and x is x plus 1. That is x prime plus 1. And we have minus 5 multiplied by y prime plus 1, and this is plus 3 dx. Okay, now before we do that, before we write it as dx, let us actually make some work. X is equal to x prime plus 1. What is going to be dx? That will be dx prime plus 0, because the derivative of 1 is going to be 0. So dx is going to be dx prime, and dy is going to be dy prime, right? So I'm just going to write it down here. Dy is equal to dy prime. So this is going to be a dx prime. So I'm just going to wipe these ones out. And we would have minus. Here this is going to be 2x prime plus 1. And this will be plus 4 y prime plus 1. And we have minus 6. And this is equal to dy prime. And this will be equal to 0. Now we can actually expand this stuff, and this would give us 2x prime plus 2 minus 5y prime minus 5 plus 3. This is dx prime minus this. this is going to be 2x prime plus 2 plus 4y prime plus 4, and this is minus 6. So we got dy prime, and that will be equal to 0. Now here we have plus 2 plus 4. That gives us a plus 6. Now positive 6 minus 6 is going to cancel out. So we actually have this stuff cancelling out. Now on the other side, we have plus 2 plus 3, which gives us a positive 5. Minus 5, that is going to be taken out. So these ones, they're going to go out. So we would actually have 2x prime minus 5y prime. This is multiplied by dx prime. On this side, we're going to have 2x prime plus 4y prime, and this is multiplied by dy prime. That is equal to 0. So this is now what we have. Now this is a homogeneous equation. So we can actually solve it using the method of the homogeneous equations. How do we do that? Now we said for homogeneous equations, v is equal to y divided by x. And you could also write it as y is equal to vx. But in this case, we do not really have a natural y, but the y primes and the x prime. So v is therefore going to be y prime divided by x prime. And so y prime is going to be equal to v multiplied by x prime. So this is basically what you need. But we know that there should also be a dy prime, as you can see over here. So what is going to be a dy prime? Now dy prime here should be, from the product rule, v dx prime plus x prime dv. Very important. You're going to use it. So I'm just going to place it here. And let us wipe out this. So the equation that we have is 2x prime minus 5y prime, and this is multiplied by dx prime minus 2x prime plus 4y prime multiplied by dy prime, and that is equal to 0. Next up, we said that y prime is vx prime and dy prime is equal to this. So we're basically going to plug it back into this equation. So that is going to be 2x prime minus 5 multiplied by vx prime multiplied by dx prime. And on this other side, we're going to have dy prime plus 4 multiplied by vx prime, and we have dy prime, which is actually v dx prime plus x prime dv, and these all is equal to 0. So we can wipe these ones out also. Now what do you think is the next thing we need to do? Here now we have dx and we also have a dv. If you have actually gone through my video on the homogeneous equations, you would actually find that in order to solve homogeneous equations, you should have a dx divided by a function in terms of x, which basically will be an x. That should be something plus or minus dv divided by a function in terms of v. That should always happen. So all we're trying to do is to make this occur or result or appear, and this should all be equal to 0. Now I have actually linked up that video to the description section, so if you have not actually gone through homogeneous equation, I recommend that you go back to that video, go through it, and that will pretty much give you a broader understanding of what we are actually doing in this video. The link is in the description section. Now going on, we actually need to make this to become 2x prime minus 5vx prime dx prime. And on this side, we're actually going to have something like this. So this will be something very big. I actually will need some space to do that. I'm just going to be more careful. So this is 2x prime multiplied by v dx prime. So this is going to be 2v x prime dx prime. We have 2x prime multiplied by x prime dv. That will give you 2x prime squared. So I need to write the squared on top. 2x prime squared dv. Next up, we have this multiplied by that. So that is going to give us a 4v squared x prime. And we need to have a dx prime right there. And lastly, we have this multiplied by this one. So that will give us a 4v x prime squared dv. For v x prime squared dv, and that should be equal to 0. Now I need to close this bracket. So we know that opening this, there should be negatives, right? So I'm just going to do that over here. So here we actually have this stuff is already in terms of dx prime, so I don't really need to put it up. This is going to be 2x prime minus 5v x prime dx prime, and here we have so what I'm going to do, I will just take out where the dx primes are, which is this and this, right? So here now we're going to have minus 2v x prime dx prime, and this is going to be minus 4v squared x prime dx prime. So this is dx prime. Now we're going to have the other one staying there. So this should be minus, and there should be 2x prime squared dv, and there will be a 4vx prime squared dv, and this is equal to 0 as usual. So here now we actually have these two stuff. We can actually add them together. So you have minus 5v x prime, and here we also have a minus 2v x prime. That should give us a 7v x prime, negative 7v x prime. This also comes into the bracket. That is because we actually have these common terms for each of them. So basically we are factoring out a dx. So that is going to be a 2x prime minus 7vx prime minus 4v squared x prime. You're going to have a dx prime over here. Then on this side, you're going to have a 2x prime squared, and we should have plus a 4vx prime squared, and there will be a dv, and this is equal to 0. So that is what you're going to have there. And next up, we need to make sure that we're going to find a dx prime over x, and the other a dv divided by a function in terms of v. So the most important thing that we could do here, we need to factor out the x primes as well as the x prime squares. So this is going to be the x prime, and here we're going to have a 2 minus 7v minus 4v squared, and this is dx prime. This will be minus x prime squared, and here now we're going to have a 2 plus 4v. This is dv, and this will be equal to 0. So I would need to clear out some stuff. Now we know that we could cancel out x prime, or I should rather say we could divide through by x prime squared. So let us try doing that. If we divide it through by x prime squared, that is going to be 1 over x prime squared multiplied by 2 minus 7v minus 4v squared, and this will be multiplied by dx prime. This should be minus 1 over x prime squared multiplied by x prime squared, and here we're going to have a 2 plus 4v, and this is multiplied by dv, which is equal to 0. Now 0 would also multiply by 1 over, so this is going to be a 1 divided by x prime squared, which obviously is going to cancel out in it. So this shouldn't actually exist. we know this is actually going to give us a 0, so we don't really need to bother about that one. So we know that there was an x prime over here. We need to add that there. So if you have x prime with an x prime squared, this is actually going to cancel just one of it. Now here we're going to cancel everything out, and this is what we should have. So we should have 2 minus 7v minus 4v squared divided by x prime. This is going to be a dx prime. And on this other side, we actually have a 2 plus 4v, and this is going to be a dv equal to 0. Now we know that we need to take this part away from this and bring it to this other side. That is because this is a function in terms of v, and it doesn't really need to stay on this side. It needs to be moved to the other side. So how can we do that? And the easiest way we could do that, we need to multiply through by the reciprocal of this representation. And let us try to do that. So that is going to be 2 minus 7v minus 4v squared, and this is raised to the power of -1, and this will be multiplied by 2 minus 7v minus 4v squared divided by x prime, and this is multiplied by dx prime. This is minus 2 plus 4v dv equal to 0. So if you took this and multiplied it with this, that should give you a 1. So that is going to give us a 1 divided by x prime multiplied by dx prime. Now if you took this and multiplied it with this, that will basically give us a real form. We would have 2 plus 4v divided by 2 minus 7v minus 4v squared. Because this is basically a reciprocal, so we could write it that way also. This is dv, and this will be equal to a 0. Because if we took this and multiplied it with a 0, that should give us a 0. So this is what we have. We have dx prime divided by x prime minus 2 plus 4v divided by 2 minus 7v minus v squared dv, and that is equal to 0. So now we can integrate both sides of the equation. So here we're going to have integral dx prime over x prime minus integral 2 plus 4v minus 2 minus 7v rather, and you have a dv, and this is going to be an integral 0. And the next thing you need to do, you need to solve this using the partial fractions. So let us try to do that. If you had a 2 plus 4v divided by a 2 minus 7v minus v squared, you can factor this out. So how can we factor it? So I think actually there was a mistake somewhere. I actually needed a 4v squared, so I'm just going to add that there. Feel free to rewind the video and go back to that place where there should actually be a 4v squared. So there should actually be a 4v squared over here. So this is going to be a 4v squared. Sorry for that mistake. Okay. Now solving this, we actually need to factorize this form. Now factorizing it, we have a -4, which should be multiplied by 2. That should give us a -8. We also have a -7. Now we know that -8v plus a v is actually going to give us something like that. So you have a 2 minus 8v plus v minus 4v squared. Factoring this, we're going to have a 2 into 1 minus 4v, and here if you took a v out, that will give you 1 minus 4v here also. So we have 2 plus v as well as 1 minus 4v as the factors of this. So this is actually 2 minus 4v and oh, that is actually 2 plus v. So I need to rewrite it. 2 plus v and 1 minus a 4v. So this is actually what you have. Now this could be split into partial fractions. So you can have this to be equal to a divided by 2 plus v plus b divided by 1 minus 4v. So that is what we actually need to work. So we're just going to do that very briefly. I need to take some stuff back. So I'm just going to take this out. Now in order to solve these partial fractions, we need to take the denominator of this form, which is actually this, and multiply it through the whole equation. So that is going to be a 2 plus 4v, and this should be a normal v, and a 1 minus 4v. So this should be 1 minus 4v. Now, if we multiply this by this form, this is actually going to cancel out. This would cancel this. And so that would just leave us with a 2 plus a 4v. And if you took this to multiply with this, you're actually going to have this cancel with this one. So that is just going to leave us with an a multiplied by a 1 minus 4v. And if you took this to multiply by this is actually going to cancel this with this. And that will leave us with this form. So that will be b multiplied by what is left. If this cancels out, what is left is going to be a 2 plus v. Next up, we need to know what values of v we might make to make a to disappear as well as b in succession. So let us start with the a. In order to find a, we need to make a b to get eliminated. And that is if you made v to be a negative 2, right? So if v is equal to 2, well, if v is rather equal to a negative 2, that is going to be 2 plus 4 multiplied by negative 2. And this is going to be equal to a. And this will be 1 minus 4 multiplied by negative 2. And of course, we're going to have this get eliminated, because that will be a b multiplied by 2 minus 2, which is going to get cancelled, because that will be a 0. So on this side, we're actually going to have a 2 minus 8, which would give us a negative 6. And on this side, we're going to have an a multiplied by 9. We know that 1 multiplied, well, that should not be multiplied. Let us just take it more gradually. So this is a 1 plus an 8. That should give you a 9. So we should have a 9a right there. So if you have a negative 6 and this equal to 9a, a would actually be minus 6 divided by 9. And this is going to be a negative 2 divided by a 3. So that is what we have. A is equal to negative 2 divided by 3. Now let us try to make the a get eliminated. How can we make a become a 0? That will pretty much come as a result of v becoming a 1 over 4. So let us try to do it. If v is equal to 1 over 4, we're going to have this. This will be a 2 plus 4 of a fourth. And on this side, we're going to have a into 1 minus 4 of a fourth. And here we're going to have a b multiplied by 2 of a fourth. So here we know this is going to be 4 canceling this out, and that will leave us with a 3. So that is going to be a 3. and on this side we're going to have an a into 1 minus 1, which gives us a 0, and here we have 2 uh, 2 added to a fourth. What is that going to give? So that should give us a 9 over 4. So we have 9 over 4b. Now, of course, we know this should be eliminated. So this is going to be 3 equal to 9 divided by 4b. Next up, we could take a 4 and multiply through to the other side. So that should give us a 12. That is equal to 9b. So b is equal to 12 divided by 9. This could get reduced. If we took a 3, divided it into this, that will give us a 4. Dividing 3 into this should give us a 3. So the answer is 4 over 3. So from here we find that b is equal to 4 over 3. So that means we have actually found what the fractions should be. Okay, so we said that 2 plus 4v divided by 2 minus 7v minus 4v squared was equal to a divided by 1 minus, well, that was actually 2 plus v. And we also had that that should be plus b divided by 1 minus 4v. Now we know what the a is. A is negative 2 divided by 3. This is divided by 2 plus v. So I'm just going to write that there. Plus a b, which is 4 over 3. This is divided by 1 minus 4v. So we can actually rewrite this stuff. So let us try to do that. This is going to be integral 1 over x prime dx prime minus integral. So for the first one, you're actually going to have minus 2 over 3. So this is 2 over 3 divided by 2 plus v. And this is going to be a dv. And here we're going to have a minus integral 4 over 3 divided by 1 minus 4v. This is dv. This will be equal to integral 0. Now, we know that negative 2 over 3 is actually a constant as well as 4 over 3. So they basically should go out. Now, if I took negative 2 over 3 and multiply with a negative 1, that is going to give us a positive. So this would actually be 1 over x prime dx prime plus a 2 over 3 integral 1 over 2 plus v dv. And here we're going to have a negative, well, there should be a negative 4/3. This is going to be 1 divided by 1 minus 4 dv. And on this other side, we're going to have an integral 0. So we can actually solve it now. This is going to give us an ln absolute x prime. And here we're going to have a 2 over 3 ln absolute 2 plus v. And the derivative of 2 plus v is actually going to be a 1. That is with respect to a v. The derivative of x prime with respect to x prime is actually going to be a 1. So there is actually none to worry about right there. And about this place, we actually have 1 minus 4v. So if you actually found the derivative of this is going to be a negative 4. So that should be a negative 4/3 and multiplied by 1 over negative 4. Multiplied by ln 1 minus 4v. And this is equal to ln c. The derivative of 0 is the same thing as ln c. In this case, we have c to be the constant. That is the logarithm of a constant, which pretty much is still going to give a constant. Now, on this side, we're actually going to have a 4 cancel out, and these negatives are going to combine to make it positive. So we should actually have something like this. ln x prime plus ln 2 plus v, and this should be raised to the power of 2 divided by 3. from the laws of logarithm. This is going to give us a plus because we have a negative multiplied by another negative. That should give us a positive. And this should be a 1 over 3. Although we know that from the laws of logarithm, 1 over 3 should go over to the other side. That becomes the power of 1 minus 4v. So this will be 1 over 3. And here you actually have ln c. And the next thing we need to do, we need to combine all this using the laws of logarithm. So this is plus, and this is also another plus. And since we have the logarithms to be in the same base, ln means log to the base e. Therefore, this is what we're going to have. We would have log to the base e, or ln of x prime multiplied by 2 plus v raised to the power of 2 over v, and this is multiplied by 1 minus 4v raised to the power of 1 over 3. And this is equal to ln c. Since we have this to be the same as this, we could well cancel them out. So this is going to get cancelled out, and this will be x prime multiplied by 2 plus v raised to the power of 2 over v, and this is plus 1 minus 4v raised to the power of 1 over 3. That is equal to a c. Now, the final thing you would actually need to do for this question, you just need to replace everything with what we said it should be. We said v is equal to y prime divided by x prime. And y prime, we said that should be equal to y minus 1, because we actually had that y was equal to y prime plus 1. So you could well replace it with this. And x prime was equal to x minus 1, because x is equal to x prime plus 1. So that could be replaced with this. And if you took everything back into the question, you would actually form or find the answer to the question. So that will be the end of this video. Now you can solve questions which are linear but not homogeneous.